Have you ever wondered what those yellow numbers on the gas pump mean? The 87, 89, or 93 as shown here? Well, in this video, we're going to dissect what these numbers really mean in terms of the chemistry behind why they came up with those specific numbers. So, these numbers here represent what's known as, you might have heard of this, the octane rating of the gasoline. And the higher the octane rating, if you go into the 90s, the more expensive the gas is going to be because this is going into the premium range. And the reason why it's called premium is because the higher octane gasoline is, for one, it provides better engine performance, but more importantly, it prevents what's called engine knock, which is when the ignitions happen unevenly or at different times within the engine inside the pistons. And this engine knock doesn't just sound bad, it results in decreased fuel efficiency and poor driving performance on that tank of gas. So let's break down the chemistry behind why this is the case for these different numbers. So the very lowest octane rating is 87. And why 87? Well, the reason why we have the whole octane rating system in the first place is because this is based on a range of 1 to 100, where 1 represents the lowest octane rating, it's the lowest, and 100 represents the highest concentration of octane. And what do we mean by octane in this case? Well, we have two hydrocarbons pictured here, and these hydrocarbons are basically long chains of carbon connected to hydrogen via single, double, or even triple bonds. But in this case, we have two main ones that are crucial in gasoline. So this top one here is called isooctane. Now here you can see octane is a part of the name, and it makes sense because isooctane is what they call the octane in the gasoline. If you have more of the isooctane, the fuel is going to provide better performance for the car. And so if you have a high concentration of this stuff, your octane rating is going to be higher. So isooctane represents the 100, the full rating of the gasoline. So that is isooctane all the way over here. Now at the other end of the spectrum, we have hexane. Now, hexane provides very poor performance in the engine because hexane is highly reactive and tends to catch on fire or explode prematurely within the piston. So here you can see you've got hexane all over inside this piston here, and before the spark plug injects the fuel which ignites inside the piston, that hexane goes off early before the spark plugs are even ready, and this causes what's called a premature ignition. So, a premature ignition is what you're going to have going on if you have too much of this hexane inside your gas tank. And like I mentioned before, the engine knock is noisy and reduces efficiency, and overall is not good for your engine. Now, so to fix that problem, what you want to do is choose a higher octane level. If your car is if you hear engine knock, it means you might be having a too low of an octane rating inside the gas tank. So you might want to step up to 89 or 93. And by doing that, you're adding more of this isooctane into the gas tank and into the engine here. You can see for the isooctane, it doesn't ignite so prematurely, and the spark plugs can actually inject the fuel and result in the reaction occurring at the correct time, which eliminates any kind of engine knock from the pistons igniting at staggered times. So, as you can see here, the numbers 87, 89, and 93 are all on the upper end of the 1 to 100 range. So as you might guess, the higher the number, the more of the isooctane you have. And the lower the number, the more of the hexane you have. Now, of course, different engines require slightly different octane levels. So, a performance sports car might demand the full premium 93 octane. For example, race cars usually need higher octane because they want to extract that extreme performance. But an average economical sedan, for example, that doesn't have an extreme need for performance, you might just be able to get by with the 87 octane without causing significant performance reductions or engine knock. And so essentially, all these octane ratings, they all come down to the presence of the isooctane and hexane within the gas tank. And as we've seen here, too much hexane results in engine knock, which is why you increase the concentration of isooctane to find the perfect balance. So that's the chemistry behind those yellow numbers on the gas pump and how they determine the performance of your engine.